Alright, so solving systems with three variables. So we do need to know how to do this algebraically, which means we gotta be able to do it by hand, okay? And it's a little bit of a pain in the butt just because it's kind of long, but it's just manipulating these equations, okay? So, here we go. What you need to do first is you need to solve for a variable, okay? Preferably one of these equations that only has two variables in it. So this guy right here, since it does not have a y value, we are going to solve for x or z. I'm going to choose to solve for x, and I'm choosing that because if I solved for z, I'd have to divide by 6, and that would give me a decimal here, and I just don't feel like dealing with decimals. But if I solve for x, I'm dividing by 3. 6 and negative 18 are both divisible by 3, so I'll get a nice answer. Okay, so minus 6z from both sides. No, I do not know why I put an equal sign right there. Alright, and we got 3x equals negative 6z minus 18, and then we can divide each piece by 3. I know some of you guys can do this whole part in your head, that's fine. Just be careful, because if you goof up one little thing on this, it's really annoying. My biggest suggestion to you would be to show more work than you think you need to, because it really is annoying to have to go back and fix this, because it's just a little bit of a longer problem. So we're going to take what x equals, and we're going to substitute it in for x here and for x here. Okay, you might want to flip over and use the back of your paper. Alright, and then, because I'm going to show you something else for example 2, so you hopefully won't need the back of your paper for it. Okay, so I'm going to start off with this guy. So do some stuff in different colors here. Back up. Alright, so we've got 6, big set of parentheses, because that's what x is, and I'm substituting something in for it, plus 5y minus z equals negative 8. So our second step here is to sub and simplify. So substitute in this guy and simplify it. So we've got negative 2z minus 6. So I'm just going to distribute negative 12z minus 36 plus 5y minus z equals negative 8. And then I'm going to combine my like terms. So negative 12z minus z is negative 13z. And then I have a plus 5y. And I'm actually going to take the 36 and I'm going to add it to the other side so that this is in standard form. Something that we will discuss in a second. So negative 8 plus 36 gives you 28. Okay, so this one is a big one. We want to hang on to this guy. We're going to need him in a second. Okay, you know what, maybe I'll just highlight all those guys in orange, because we're going to have to go back to this one as well. Alright, and then we're going to do this guy. So pick a different color. And sneak over a little bit. And we've got negative x, and again we're substituting in for x. I'm going to put a big set of parentheses, plus 3y minus z equals 14, and I am substituting in my negative 2z minus 6. So again, I'm just going to distribute the negative. Remember, it's a negative 1 there. So that gives me 2z plus 6 plus 3y minus z equals 14. Again, combining like terms. Okay, And like the math part of this, you guys know how to do this. You know how to distribute, you know how to combine like terms. So the math piece isn't terrible. It is just a longer problem. Okay, and again, I'm going to put this in standard form, so I'm going to subtract 6 from both sides. You'll see why in a moment. And that will give me 8. Okay, and then this is my other big one that I want to hang on to. Okay, alright, so here are my equations. 1, 2, 3 right here. And we are going to, now that we have this guy and this guy, we can combine them because they only have 2 variables. This is just good old solving systems of equations, which I know we're going to need to review, so don't worry, we'll be doing some of that next class as well, because we're just taking it to the next level here. So if you have negative 13z plus 5y equals 28 and z plus 3y equals 8, this screams elimination because it's in standard form. And since we have a negative 13z and a 1z, I am going to choose to multiply this entire equation by 13 so that my z's will cancel out. So doing a little elimination. So I'm going to end up with 13z, 3 times 13 is 39y, and 8 times 13 is 104. Yes. Alright, 104. So, if we add these guys up, this one goes away. I end up with 44y equals 132. And when you divide here, you finally get one of your answers. And then everything falls into place. You should get that y equals 3. That is like the big kahuna. There's one of your pieces. Then, since you know what y is, you can substitute it in to either this guy or this guy. Since there's no coefficient of z, this one will be a little bit less work. Okay? So this is where everything kind of unravels nicely. So I have z plus 3 times 3 equals 8. That's z plus 9 equals 8. And when I subtract 9 on both sides, I get that z equals negative 1. Again, there's one of my big answers. And then because I know what z is, I can substitute it back in here, and I can get what x equals. So x equals negative 2 times negative 1 minus 6. And that gives me 2 minus 6, so x equals negative 4. And there's my last big answer. So remember, midterm and final, I can't give you much partial credit at all because I have a very, very strict rubric. So when you're solving a system, right, these are all kind of lines. Normal systems of equations, normal just x and y ones are linear that we've been doing, so it's where 2 lines cross. This is just 3-dimensional, which we'll look at a little bit. It's kind of cool. So your answer is still a coordinate. It's still an x and a y, but then it's also a z. So my x is negative 4. My y is 3. And my z is negative 1. So negative 4, 3, negative 1. This is a final answer. Where's my highlighter? There it is. So this guy right here is your final answer. Okay, make sure that you write it as a coordinate. Alright? So, take a minute, kind of go back through that. I know my work's a little bit everywhere. Try to do it in different colors for you. Hopefully yours is nice and linear. Okay? And make sure that you can kind of go through that process. The actual algebra you're doing is not super, super crazy, okay? It's just a little longer, and you got to keep, in mind of things. So maybe you want to bust out some highlighters or colored pencils to kind of color code things or section up your paper, okay? All right. Let's try this guy. So one thing that you are going to see is you're going to have to solve things algebraically, but you can solve them them with matrices, which is why this is in this unit. So, solve with matrices. And a word that you are going to see is augmented. Okay? So we'll look at that a little bit as well, just to make sure you understand what directions are telling you to do. So first thing we want to talk about, that standard form, okay, is always something x plus something y plus something z equals a number, okay? That is standard form. If you're just doing a linear x and y, you would just eliminate the c and z part, okay? So what we're going to do here is we're going to put these into standard form, okay? So this guy's already got a 2x. I have a minus y, so I can add the y over to the other side, which would give me a plus 1y. I am going to put 1s in here, and you'll see why. It makes it a lot easier. Got a minus 2z, and that's going to equal 4. If you need to take these out separately and solve them algebraically, please do so. Showing your work, okay? Second guy here, no x's, so that's 0x. Yes, you need to write that in. Plus 2y minus 4z equals 2. And then this last guy, no x's. Ooh, let's do a different color. Color coding is always fun. No x's, no y's, and to get this z to the other side, I'm just going to subtract it over. So minus 1z equals that 2. Okay? So now that it's in standard form, this is pretty freaking awesome, okay? We are going to pop it into a 3 by 4 matrix. So it's always going to be a 3 by 4 for these. Okay? My first row is 2, 1, negative 2, 4, 2, 1, negative 2, 4. My second row is 0, 2, negative 4, 2. That's why writing in those zeros is helpful. And my last one is 0, 0, negative 1, 2. Okay, this is why we looked at calculator steps before you left last class. So if you take your calculator out, if you have a calculator, if you don't have a calculator, come in the morning and see if you can try it, okay? You're going to go into second matrix, and you're going to go over to edit, and you're going to edit the matrix. We'll call this matrix A, okay? And you're going to make it a 3 by 4. You're going to enter in your data, and then remember, you always need to quit. So second quit, okay? And then you're going to go back into second matrix, and if you arrow over 1, so second matrix is on the x to the negative 1 button, and if you arrow over to where it says math, and you go down the list to option B, you're going to see something that says RREF. Be careful that you do B, not A, because A is just REF, and that is a different thing. So you're going to do RREF, and then you're going to go into second matrix again and choose matrix A. And if you hit enter, this is super awesome. If you hit enter, you're going to get a matrix. So once you RREF this, you're going to get a matrix that says 1, 0, 0, 0, 1, 0. My zeros are looking like 6s. I am so sorry. 0, 0, 1, and then 1.5, 1, 1.25. This guy right here is an identity, which we talked about that first day a little bit. Okay? All 1s and 0s, 1's going down in a diagonal from the top left to the bottom right. This guy right here is your answers. This is what x equals, this is what y equals, and this is what z equals. And this does work with linear functions as well. Pretty freaking awesome. So then you can just jump right to your answer, 1.5, 1, 1.25. Alright, so if it's so easy in the calculator, why do we need to do it algebraically? Well, the algebra practice is good. They want you to for the AccuPlacer and different colleges that you're going to. Um, but the beauty is you can check your work in the calculator. And so if you're getting stuck on one of the numbers, as you're going through, you can tell whether you're doing the algebra correctly, so that you don't have to go back and redo the whole problem. Okay? So just kind of keep that in mind. I know it's annoying to do it in algebra. Suck it up. You'll be fine. All right? And I'll show you, we'll do the last one as a calculator as well, just to get it into standard form. So, one more. Let's look at the word problem. So we've got to make the equations here, but they're not too bad. So a vendor sells hot dogs, chips, and drinks. So there's your three variables right there. So we'll use H, C, D. So a customer buys 2 hot dogs and 5 chips and 2 drinks, and it costs them $10.50. Okay. The price of 1 hot dog is 50 cents more than 1 chip. So 1 bag of chips. So if I buy a bag of chips, I'd have to spend 50 more cents, ooh, dollars, that'd be crazy, for a hot dog. Okay? So chips plus 50 cents is a hot dog. And then 1 drink is $1.75 less than 2 hot dogs. So if I bought 2 hot dogs and then I took away $1.75, I would get the price of a drink. Okay? So this is set up really nicely for algebraic because you're already solved for H and you're already solved for D. If you choose to solve it algebraically, I will give you an extra point or 2 on your homework. Probably 2. That's a lot of work. If you attempt it and you get pretty close, I'll give you 1. If you attempt it and you get it correct algebraically, I will give you 2. Okay? And you get to use the calculator to your advantage, so please, please, please do that. So H, C, and D, you can replace them with X, Y, and Z if you want to. I don't care. It's just whatever order they're in, first, second, and third. That last matrix for your answer will be first, second, and third. Okay? So let's bust this into a matrix, shall we? So we need standard form. Let's do standard form first. So we've got 2H plus 5P plus 2D already in standard form, and that's 1050. This guy, I've got 1H, I've got a C over here, so I'm going to have to subtract it from both sides, so minus 1C, and no drinks gives me 50 cents. And this guy right here, I'm going to have to subtract the 2 hot dogs over. So I've got negative 2 hot dogs. I've got no chips. And I've got 1 drink. And that is a negative 175. Okay? Alright. And then we can put this into a lovely matrix. So, here we go. 2, 5, 2, 1050, 1, negative 1, 0, 50 cents, negative 2, 0, 1, negative 1.75. Okay? And again, you're going to go in. This is going to be a 3 by 2 second matrix. Go over to Edit, put in your values. Okay? And then you're going to go to make sure you quit, so second mode. Go into second matrix, arrow over 1 to math, and go to RREF, and then go back into matrix and pick matrix A, and it will give you an identity matrix, and then it will give you your lovely answer. So, a hot dog, in this case, is let me see, where's my answer, sorry. I actually solved this one algebraically first. So it should give you 150. It'll probably just say 1.5 though. The second variable we did was chips, which is just 1 because it's $1. And then the second one last one is drink, which is 125. This one you would not answer in a coordinate because we're talking about a word problem. So you know how we solve word problems. Write your answer in a sentence And I'll even use my little pen tool here so you guys don't have to deal with my handwriting anymore. And we'll be good. So, actual answer should say a hot dog costs $1.50, a bag of chips is $1, and a drink is $1.25. Alright, so, not too bad, you can handle it. We'll practice a bunch next class. Alright, and then we will move on with life as always.